So let's get to the problem. So let's read it. Given H050 HR steel. Okay, so apparently we're given the steel because we need to probably get the data from this particular table. Now we're given that the specimen has the cycles 10 raised to 6. Oh, sorry, estimate the rotating endurance limit. So given n, we need to compute the endurance limit, which I think is SE. This is asked. This is given, n is given. Okay, and the endurance limit of a polished rotating beam specimen corresponding to 10 raised to 4. So we again given the cycles. For polished rotating beam specimen, cycles to failure. Okay. So I'm assuming that when we talk about this, it's in the region 2 we talked about, where the curve is SF equals A n raised to B. So I'm guessing that we know n, we will be able to compute SF from this. So I think we have to find SF here. Okay, and then the expected life of a polished rotating beam under complete reverse stress of this. So here we're given the stress 55 kpsi and asked to compute expected life, which is n. Okay, so let's do them one by one. So first of all, endurance limit for 10 raised to 6 cycles. Okay. So why 10 raised to 6 cycles? Well, if you look back at the idealized curve, you see that at 10 raised to 6, it's basically SE. This is basically in region 3, where you need to compute the endurance limit. So the question is, how do we compute the endurance limit? Right? So we saw that to compute the endurance limit, we have to use these formulas. Okay, so we need to know the ultimate strength SUT in order to compute SE. Let's go back. So as I said, this is going to be, this question is strictly in region 3. This question is in region 2, like I said over here. I think this is also in region 2 because you have to use the equation. Okay, so let's see. As I said, we need to compute the endurance limit. So we need SUT. Maybe it's in this table. So we have H050 HR steel. H050 is here. HR is here. So need to see something over here. Let's see what these mean. This is yield strength, SY. Fifth, this is tensile strength. Maybe this is the one, SUT. So we need this value. Okay, so we have two values here. One is in MPa, which is in SI units. One is in IPS, KPSI. The question is, which of those two should we use? Well, we have something in here in KPSI. So I'm inclined to use the KPSI value, 90 KPSI. So let's use this value because I think that eventually we want to solve everything in KPSI and not in SI units. So we have S, so part A, SUT is 90 kpsi for H050 HR steel. That's the first step. Next step is to compute SE. So we know that SE is, well, this is an MPa. Do I have it in? Oh, there it is. I have it in kpsi. So if it's less than 200 kpsi, which it is, then the formula is 0.5 SUT. So we can write, since SUT is less than 200 kpsi, We have SE is 0.5 SUT. So 0.5 times 90 is 45 kpsi. So that's the answer to the first question. The next question is compute the endurance strength of a polished specimen corresponding to 10 raised to 4 cycles. So here we are given n equals 10 raised to 4. We need to compute SF. Okay, and you can verify this. If we go to the Adler's curve, we see that 10 raised to 4 is here, so it's in region 2. So you're all good. So we need to use this equation. Back. So the equation we need to use is SF equals A n raised to B, which means now well, we know this. We need to compute A and B, and then we can compute SF. Okay, let's look at the formula for A and B, which we derived just some time back. A equals F times SUT square divided by SE. So let's compute this. Oh, we don't know, well, we know SUT, we know SE, we just computed that. We do not know what F is. So question is, how do you compute F? Let's go back to this formula. Well, there are two ways to compute it. Well, you could use this graph or you could use this formula. So if you use this graph, you need to see where SUT is. So it's 90. So if you go along this, looks like this is where F should be, and this value is, looks like this is 0.85. So it's somewhere between 0.85 and 0.86. And I'm just going to make a guess, 855. You could use any value from 0.85 to 0.86 because it looks like it's there. You could also use this formula. Since the SUT is between 70 and 200, if you use this formula, you'll get a much more accurate value. But let me just use that from the graph. Either one is fine. Let's go back. F is 0.855 from F versus SUT curve. Okay, so here we go. We have 0.855. SUT is 90, the whole thing square, divided by SE, which I just computed as 45. So A comes out to be 131.58. Okay, next we compute B. B is 1/3 log to the base 10 SE divided by FSUT, 1/3 log 10. SE is 45. F is 0.855. SUT is 90. So B comes out to be minus 0.0776. Okay, so we've computed A and B, and we know what N is, so let's compute SF. SF is unknown. A, we just computed as 131.58. N is 10 raised to 4 and B is minus 0.0776. So SF is will come out to be 64.39 kpsi. So that's the answer. Okay, and one more question to go. That is expected life of a polished specimen under a loading of sigma equals 55 kpsi. So we need to compute n. So use the same formula as before. So SF equals sigma equals an raised to b. Sigma is given as 55. A is known, it's 131.58. N is unknown. P is minus 0.0776. So in order to solve something like this, you will do, you could do it this way. N equals 55 divided by 131.58. So I took this down, and then I need to take the 1 divided by minus 0.0776. You could also use logs if you think that's better. So using this formula, we get n equals 7.62 times 10 raised to 6, or sorry, 10 raised to 4 cycles. So we can just round this up. It's 76,000 cycles. 76,000 cycles before it fails.